we have discussed this one, like methods of preparation of alcohols from alkenes. Okay, so just go through the recording lecture. And if there's any doubt, let me know. And
Okay.
please don't miss the class. Okay, so Ali, have you done this question?
Yes, ma'am.
Okay, so let me first explain it to Rinda. So see Rinda, so it's a reaction with the reaction of your carbonyl compounds with Grignard reagent. So see, by the reaction of carbonyl compounds when treated with the Grignard reagent, so it will form a corresponding alcohol. So suppose we have a aldehyde. Suppose we have just see the let's understand the mechanism. It's very easy mechanism. So this is your carbonyl compounds. You know very well what is carbonyl compound? The compound which contains the CO group. Okay. So you know very well aldehyde as well as ketone both have CO group, right? So aldehyde have CHO. Aldehyde is CHO group, and what about the ketone? Ketone is this one. Only CO group, and on the right side as well on the left side there will be a alkyl group. Okay, R. So when you take the carbonyl compounds and when you treat it with your Grignard reagent is RMgX. Okay, so when the when it is attached to the alkyl, okay, alkyl group, so it always, because this magnesium is a metal, right? So it is electropositive. So this will acquire partial positive charge, and this alkyl group, which is attached to this magnesium, will acquire partial negative charge. Okay, so and what about this one, carbon and oxygen, this bond? So this oxygen is more electronegative, right? So this will acquire partial negative charge and this carbon will acquire partial positive charge. Okay, so this alkyl group will attract this carbon. Okay, ये इससे जाके attach हो जाएगा and the bond will shift over here and यहाँ पे negative charge आ जाएगा. Okay, now see this one. Okay, so this R group, alkyl group, get attached to this. Okay, get attached to this carbon, and here there will be a negative charge on the oxygen. Okay, so here on the oxygen there is a negative charge. So this MgX, which has a partial positive charge, it gets attached to this one. Okay, you know very well the unlike charges attract each other. So this is unlike, this oxygen has negative charge, so magnesium has positive charge, so it get attached to this oxygen. Now, when further hydrolysis after, okay, on further hydrolysis, okay, when you add water to this compound, so water has H plus and OH minus ion, right? So this oxygen, which has a negative charge, so hydrogen H plus ion will get attached to this oxygen, and this MgOH Lex. You will get this one. So basically, this will form your corresponding alcohol plus your MgOH. Okay, magnesium hydroxide का chloride, this salt. So that is your proper mechanism of this reaction. Proper mechanism. Now we have formaldehyde, other aldehyde, means other than formaldehyde, and the third is your ketone. So see, when you treat this, when you use this reaction, and when you treat the formaldehyde with the Grignard reagent, so you will attain primary alcohol. So primary alcohol will be formed. Okay, on the treatment of formaldehyde with the on treatment of Grignard reagent, right? So formaldehyde plus Grignard reagent, so it will give you primary alcohol. Similarly, other aldehyde other than formaldehyde, when you take, so when you treat it with Grignard reagent, so you will get secondary alcohol. The mechanism will be same. आपको same mechanism follow करना. Third one, ketone. When ketone is on treatment with your Grignard reagent, it will give you a tertiary alcohol. Will give you a tertiary one. So that's the process, that's the whole reaction. Okay, that we have done in the previous class. That was the last one. Clear, Imda?
Yes, ma'am.
Okay, when we will do the question, it will be more clear. Suppose we, yeah, I have given this question in your homework. Okay, so first question is HCO. What is this? This is a formaldehyde. Okay, and you know very well, formaldehyde on treatment with Grignard reagent, it will give you a primary alcohol. Okay, now let's see. Suppose this is your HCO. CHO. CHO. So this is a formaldehyde. Plus, what is Grignard reagent over here? First step में you will treat this formaldehyde to Grignard reagent CH3 MgBr. Okay. Now what happens? You know very well. This Mg is attached to this alkyl group, methyl group over here. So it will acquire partial positive charge because it is a metal. It is electropositive. Okay, and this methyl group will acquire partial negative charge. Similarly, between this carbon and oxygen, this carbon will acquire partial positive charge because it is more electropositive than oxygen. Right? So oxygen is more electronegative between these two. So this carbon will acquire partial positive charge. Now it's very simple. The CH3 will get attached to this carbon. ये इस पे attack करेगा and this bond will shift. So what you get? You will get CH. I'm writing it like this. H. Okay, one H and second H. And this will acquire negative charge. Okay, this oxygen will acquire negative charge and this CH3 get attached to this carbon. Just like that. Okay, and this whole group, this MgBr, which has a partial positive charge, is get attached to this oxygen, like MgBr. Okay, it has a partial positive charge. Now, in the second step में क्या करोगे आप? You will just add water to it. Hydration कराओगे. Now, hydration कराओगे तो you have H plus. It will dissociate to form H plus and OH minus sign. So H plus will get attached to this oxygen and it will give you a primary alcohol. So this H, C, H, CH3 and here OH. This hydrogen will get attached to this oxygen and plus MgOH. This will be your product. Okay, and you can just arrange this. How you can write down? This is CH3. Okay, this is CH2. What is this? This carbon has two hydrogens, so you can combinedly write like this: CH2 and OH. Okay, so it's very simple. You can see you will get you just get the primary alcohol. So when formaldehyde on treatment with any Grignard reaction, so our group can be anything: CH3, C2H5, anything. Okay, so it does not depend on the alkyl group. It only depend on the formaldehyde. So when formaldehyde is treated with any Grignard reagent, so you will get a primary alcohol. Is it clear, Vimdha?
Yes, ma'am.
Now let's do these questions. Yes, Ali will tell me. This second to fifth question was your homework. Okay, so tell me the product, Ali, in the second question. At CHO, formaldehyde when treatment with CH3, CH2, MgCl. So here the Grignard reagent is C2H5, ethyl group. Okay, you can see clearly the CH2 is C2, CH2. Yes, Ali, tell me the final product.
C2H5 CH2OH.
C2H5 CH2OH. Okay, that is your product. Okay, quickly write it down. You can just write on CH3, CH2. ऐसे लिख सकते हो, just a second. Okay. See. Okay, let's understand the mechanism in the because you didn't join the class yesterday. So let's understand this. How you get this one. So suppose this is your HCHO, right? Plus this is your MgCl. Okay, so this magnesium will acquire partial positive charge and this carbon will get partial negative charge. And this carbon and oxygen, between these two, the carbon will get partial positive charge. Okay, so this carbon from here, this carbon will get attached to this. आपने यहाँ से attachment show करना है and this bond will shift. So what you get? You will get H, C, H over here, oxygen, negative charge, and you will get MgCl. And here, what you get? CH, CH2, CH3. Okay, CH2, CH3 means ethyl group over here. Now, when you further hydrolysis कराओगे H2O, so H will get attached over here, and you will get CH3, CH2, CH2, and OH. So basically you will get propanol. Propanol plus MgOHCl. Okay, clear?
Yes, ma'am.
Okay, do the next one. If you have written, I'm going to erase it. Just quickly write it down, the whole mechanism. Written?
Yeah, ma'am. Done.
Yes, I'm going to erase it. I will only write now because the mechanism is clear to you all. So you can do the mechanism by yourself now. And just, I will write the product only because we don't have much time. We have to complete this chapter. Now see. So in the second one, what is the product to CH3, CH2, CH2, and OH. Okay, so no need to write down the byproduct, just write down the major product. Now in this one, you can see what will be the Grignard reagent. So Grignard reagent is this MgCl. On the second carbon, MgCl is attached. Right, so you have to attach this from here. Okay, you have to attach. Okay, let's understand this mechanism. So CHO, right? So this is your aldehyde again, HCHO plus your this one. This is the Grignard reagent. So again, you know very well, this magnesium will acquire partial positive charge, and this carbon, this central carbon, second carbon will acquire partial negative charge. And this one will partial positive charge. So you have to attach this carbon. This carbon will attack this carbon. Okay. And this one will shift over here. So you will get HCHO minus. And here on this carbon, 1, 2, 3. On the second carbon, you have to attach. So you will like this. Okay. So CH3, CH2, and CH3. Just like that, you will write. Now, plus this MgCl will get attached to this one. Now, further hydration karoge. Okay. So, we'll give you HCH and here plus OH plus MgOHCl. Right. Now, you can write down this one. This one आप कैसे लिख सकते हो? Like this. This carbon, this has CH3, CH3. Okay, now this CH2 and OH. So this is your proper major product. This is your major product. So again, this is your primary alcohol. Okay, this OH group is attached to this carbon, and this carbon is further attached to only one carbon, only one group. Okay, so this is your primary alcohol. So when formaldehyde is treated with any Grignard reagent, whether it's an iso group, whether it's just a straight chain group, or any alkyl or any Grignard reagent, so you will get a primary alcohol. Okay, the next one. Yes, Ali, tell me the next product. Fourth one.
CH3, CH3, CH2,
CH3,
CH2, OH.
CH3, CH2, CH2OH. You said this one.
Ma'am.
Are you sure? Just quickly do the mechanism. And after doing the mechanism, just let me dance. Yes, Rimda, you too. Just write on the mechanism. And then let me know if it is correct or not. Because see, as I told you, other aldehyde, other than formaldehyde, when on treatment with Grignard reagent, it will give you a secondary alcohol. And you said in your answer, it's a primary alcohol. It's a propanol. Because it's wrong. The statement becomes wrong over here. Because other alcohols go when you treat it with the Grignard reagent, so you will always get a secondary alcohol. Formaldehyde on treatment with the Grignard reagent will give you a primary alcohol. So this is a primary alcohol, which is wrong. You will not get a primary alcohol. Just quickly follow the mechanism. Okay, it's a proper mechanism. Likho, then you will get to know what will be the product. Okay, just quickly do that. So this is wrong.
CH3, CH, OH, CH2, CH.
Okay, CH3, CH, OH. Okay, and next, Ali,
CH2, CH3.
where? On which carbon? Here, this carbon, CH2, CH3.
No,
Yes.
ma'am. OH is on that carbon.
OH is on that carbon. Yeah, OH is on that carbon, and CH2, CH3 is again on this carbon. Is it correct? You
Yes,
got
ma'am.
the same product? Yeah.
Yes,
So
ma'am.
this one is correct answer. Okay, if you want to understand the whole mechanism, then see CH3, okay, CHO plus you are just treating it with this Grignard ring, CH3, CH2, MgCl. Again, the trick is very simple. You have to follow the same mechanism. Okay, so this is your R group, alkyl group. Okay, R MgX. This is your Grignard reagent. So this magnesium, it will acquire partial positive charge, and this carbon, which is adjacent to this magnesium, will acquire partial negative charge. So this carbon will get attached to this one. Okay, so and between this is partial positive charge. So ये क्या करेगा? This carbon is attached, and this bond will shift over. So you will get CH3, and here this carbon, writing hydrogen over here, oxygen P, negative charge, and here this whole thing. From where you will attach, so from this carbon, so you will write CH2, okay, and CH. This I have attached this alkyl group on this carbon. And what about this MgCl? So MgCl will get attached to this oxygen. Now, on further hydrolysis, H2 do gap. So H plus will get attached to this oxygen. CH3, CH, OH, and here CH2, CH. Okay, plus you will get MgOHCl. Now you can rearrange this one. This is structure. What is this structure? This is your acylic structure. CH3, CH2. Okay, and this is what is this? This is your CH. Okay, and CH, there is a CH3 group, and here OH. So you can see this is your secondary alcohol. You got the secondary alcohol. OH is attached to this carbon, and this carbon is further attached to two groups, methyl group and here CH2. So that is your secondary alcohol. So that's what I want to show you. Like when you treat the other aldehyde with a Grignard reagent, so you will always get a secondary alcohol. If you are not getting a secondary alcohol, it means you have done something wrong in the mechanism. Okay, so just check the mechanism, whole mechanism. You will get the correct answer. Now, what about the fifth one? Rimdha will tell you the fifth answer. If you do that, okay, written this mechanism. Can I rub this?
Yes, ma'am.
Hello, Kutsia. Good evening. Hello, am I audible, Kutsia?
Ma'am,
Am I audible? Why you have joined so late?
facing some issues.
Yeah, because we are doing for you only. Like Kutsia, you and Lubna. You guys have your exam on 5th November, right? And we are just trying to complete the syllabus as soon as possible. But you guys are not joining the session. Yesterday also you guys were not there in the class. Why?
Ma'am, we had some school event yesterday.
Okay. Okay, so no issue, just go through the recording lecture. And if there's any doubt, let me know. Okay, so we were just doing the methods of preparation of alcohols by a carbonyl compounds. Okay, so fifth one. So let's understand the mechanism. The fifth question. So this is a ketone, right? And you know very well the ketone on treatment with the Grignard reagent, so you will get a tertiary alcohol. What you get? You will get a tertiary alcohol. So Kutsia, please concentrate over here and just try to understand the mechanism. So what is the mechanism of this reaction? So when alcohol or any aldehyde on treatment with your Grignard reagent, so it will give you a corresponding alcohol. When formaldehyde, HCHO, see this, when formaldehyde, when you treat the formaldehyde with Grignard reagent, RMGH, so you will always get a primary alcohol. सेकेंड अदर एल्डिहाइड के साथ आप ट्रीट करते हो Grignard reagent को, okay, so you will get a secondary alcohol other than formaldehyde. Formaldehyde plus Grignard reagent, so you will always get a primary alcohol. Other aldehyde plus Grignard reagent, so you will get a secondary alcohol. And ketone on treatment with the Grignard reagent, so you will get a tertiary alcohol. Okay, let's understand the mechanism. Okay, I'm just writing this fifth mechanism, the ketone one. You have to follow the same mechanism for all this type of question. See, this is a ketone, right? This is ketone, and you have this Grignard reagent. Grignard reagent. RMG. So what is R group here? So R is basically a cyclopentane. What is our R group? So R is your cyclopentane, a pentyl बोल सकते हो आप. So and what is this? This is your ketone. So you can see whenever the Grignard reagent Mg, magnesium metal, is attached to the alkyl group, so this magnesium metal is electropositive. Metals are electropositive, you know very well. So it will acquire partial positive charge, and this corresponding, this adjacent carbon will get a partial negative charge. Okay, now done. See this. This is ketone, and the ketone is, this carbon is attached to this oxygen. So between the carbon and oxygen, which one is electronegative? Oxygen is more electronegative, so this oxygen will get like negative charge, and this carbon will get partial positive charge. Okay, now see what happens. This carbon, just a magnesium attached, this carbon will come and get attached, just attack on this carbon. इस carbon पे attack, ketonic carbon पे ही attack करेगा. Why? Because this carbon is electronegative Okay, it has a partial negative charge, so the negative part get attached to the positive one, and this bond will shift over here. So what you will get this CH3, right? This carbon. Okay, just a second. Let me show like this. Okay, so what you will get, this is your this whole thing. Okay, this group CH3 C and this carbon CH double bond O and this CH3. This bond I have just joined like this, and oxygen way there is a negative charge. Okay, oxygen will where this bond will shift over here, and this oxygen will get negative charge, and this cyclopentane ring get attached to this carbon. So here, from here, you will show the attachment like this. This one. Okay, so see this carbon get attached to this carbon, and we will show like this carbon and carbon attachment like this. Okay, and this oxygen will get negative charge. So this whole thing MgBr will get attached to this oxygen. MgBr, which is positive. Now further hydration of the H2O. When you treat it with H2O, so H2O, you know very well, it will ionize to give H plus and OH minus ion. So H plus will get attached to this oxygen, and MgOHBr you will get. So what you will get? This thing and OH. So you are just getting the alcohol plus MgOHBr. That is a byproduct. So again, you can see this is which type of group it is. Which type of alcohol it is? It is tertiary alcohol. So OH hydroxyl group is attached to this carbon, right? And this carbon is further attached to how many groups? One methyl group, two methyl group, and this cyclopentane. Three groups. So it is a tertiary alcohol. It's a tertiary alcohol. So treatment of ketone with the Grignard reagent will always give you a tertiary alcohol. Is it clear to everyone?
Yes, ma'am.
Okay, Rimdha, Ali, is it clear this question?
Yes, ma'am.
Now see, suppose we have a question. You have to convert ethyl bromide to propanol. Ethyl bromide to propanol. So what is ethyl bromide? So haloalkane से आपने क्या करना है? Propanol में convert करना है. Haloalkane to propanol alcohol. Okay, so how you will convert? Let's see. Let's observe, let's analyze this question. So ethyl bromide. So for this type of conversion question, first you have to write down the reactant and product. So what is the reactant over? You have to convert ethyl bromide. So what is ethyl bromide? This CH3, CH2Br, this group. So ethyl bromide is, you have to convert this ethyl bromide to propanol. Propanol. So 1, 2, 1, 2, 3, and here OH. So you have to convert this to a propanol. Now let's understand the mechanism, or let's first analyze this question. So this is ethyl bromide. So how many carbon is there? 2 carbon. And in the product side, how many carbon is there? 3 carbon. So you have to increase 1 carbon, and you have to replace this bromine group by a OH group. Okay, that thing you have to do for this question, for this conversion question. Okay, so one carbon आपने add करना है, right? And you have to replace this bromine to by OH group. Now, so what we can do? For example, if suppose आपने this is ethyl bromide, and if you do the SN2 type of mechanism, आपने nucleophilic substitution reaction करा दिया. Suppose we just add the aqueous sodium hydroxide. Aqueous sodium hydroxide. So this aqueous sodium hydroxide will give you OH minus ion. This OH minus is a nucleophile, right? So it will act as a nucleophile. So this carbon, this bromine is a good living group, right? So this this OH will get attached, will attack this carbon, and this bromine group will leave. You will get 1, 2, and this OH. But this is not your product. If you do the substitution reaction, nucleophilic substitution reaction, then you will not get the desired product, because you have to convert ethyl bromide to propanol, not ethanol. You have to increase one carbon. You have to increase one carbon. So this mechanism is not basically it is not correct for this type of question because you have to add one carbon. तो आप कैसे add करोगे one carbon? Okay, so let's see how we can achieve this one. So first, if we can, this is ethyl bromide. If ethyl bromide में हम magnesium metal के साथ react करें, ethyl bromide alkyl, your haloalkane on treatment with the Mg magnesium metal, so it will give you a Grignard reagent. How the Grignard reagent is prepared? So Grignard reagent is prepared by the treatment of haloalkane, okay, haloalkane by a magnesium metal. So you will get a Grignard reagent. So what will be the Grignard reagent over here? 1, 2 carbon. Okay, this is your alkyl group, and here MgBr. Okay, this Grignard reagent you get. Clear this step? Yes or no? Just please respond.
Yes, ma'am.
Okay, now see. Next step. This is your Grignard reagent. Now, can we do this type of reaction like when you add formaldehyde on treatment with, because you have to, this is this primary alcohol. आपको primary alcohol चाहिए. This is your primary alcohol. Propanol is a primary alcohol. You have to, at last, you have to convert this ethyl bromide to a primary alcohol, propanol. So primary alcohol, when Grignard reagent is treated to a formaldehyde, it will give you a primary alcohol. So can we treat it with the formaldehyde? So yes, we can. So in the first step, we will treat it with HCHO, formaldehyde, and be followed by the hydration, H2O. You can do the whole mechanism. You will get this. You will get a propanol, right? So you will get a propanol. So these two steps. So by this two step, you can convert ethyl bromide to a propanol. So this is a Grignard. If you know the mechanism, this is a Grignard reagent, MgCl. Plus, you are just using the HCHO. Okay, and just a second. Let me draw the formaldehyde like this. Just follow the same mechanism. This is formaldehyde. Again, this will have the partial negative charge. This will have the partial positive charge. This carbon will have the partial positive charge, right? So this carbon will get attached to this one, and this one will shift over here. So you will get HC, okay, H, this is oxygen minus, and here MgCl will get attached, and 1, 2 carbon. Okay, 1, 2 carbon, so CH2 and CH3. So further hydration, अपने H2 दिया, so H plus will get attached to oxygen, will give which give you CH3. Okay, so which is CH3, CH2, and this CH2 and OH. So it will give you CH3 and that direct negative CH3, CH2, then CH2 and OH. What is this? This is a propanol. Okay, you just got the propanol. That is the question. You have to convert the ethyl bromide to a propanol. So no need to write on the byproduct over here, MgOH. We should just write on the this product. So how we can prepare the convert ethyl bromide to a propanol? First, you have to treat it with the magnesium metal. Okay, ethyl bromide on treatment with magnesium metal, it will give you a Grignard reagent. Once you get the Grignard reagent, just treat it with the formaldehyde followed by the hydration. So you will get a number of carbon will be increased. One number of carbon will get increased, and you will get a propane. Is it clear? This conversion part?
Yes, ma'am.
Okay, just quickly write it. Done? Okay, tell me one more thing. Can we schedule your next class? Like your next class is on 25th, right? Saturday, 25th, upcoming Saturday. So actually, my brother's wedding is on 25th. So I'm just thinking, can we schedule that class on Friday, like 24th? 24th of October को क्या हम shift कर सकते हैं next class?
Yes, ma'am.
Okay, what about you, Rimdha, Ali? Are you guys comfortable?
Ma'am.
Yes, ma'am.
Okay. Okay, so we are just shifting the 25th class on 24th, Friday, the upcoming class. Okay, so the next method of preparation is from the carboxylic acid. Okay, so we have done the carbonyl compounds, the preparative method from the carbonyl compounds. Now it's from the carboxylic acid. How we can prepare the alcohol from a carboxylic acid? So again, when you reduce the carboxylic acid, so carboxylic acid is reduced by a strong reducing agent, just like your lithium aluminium hydride. So it converts this lithium aluminium hydride is the strongest reducing agent. So it has the ability to convert the carboxylic acid to a primary alcohol. So when you treat the carboxylic acid with a lithium aluminium hydride, okay, just strong reducing agent, so it will reduce the carboxylic acid to a corresponding alcohol, primary alcohol. Okay, now let's see. With the same number of carbon number should be same. Just keep this in your mind. The number of carbon should be same. So let's see. This RCOOH, this is carboxylic acid, on treatment with lithium aluminium hydride. So what it does, so it basically it reduces. आपको क्या करना है? The number of carbon should be same. बस इससे आपने क्या करना है? Just prepare the corresponding alcohol. So RCH2OH. It will give you RCH2OH. Okay, so you can see the number of carbon is same. Okay, you have only just carboxylic acid को आपने reduce कर दिया. Okay, the reduction is basically the addition of hydrogen. The addition of hydrogen or the removal of oxygen. So that is the reduction. So this carboxylic acid is getting reduced to a primary alcohol, okay, in the presence of lithium aluminium hydride. So the number of carbon should be same. So it is one carbon. So RCH2OH. RCH2OH. Clear?
Yes, ma'am.
Okay, now if it is clear, then do this question. Question number 1, 2, 3, and 4. It's very easy. You can do it quickly. And carboxylic acid, lithium aluminum hydride is the strongest reducing agent. It can reduce any of the three, whether it's a ketone. So ketone will get converted into a corresponding alcohol. Carboxylic acid will get converted into a alcohol. So it is strongest reducing agent. It has the ability to reduce each and every group. What will be the first? Yes, Rinda will tell me. What will be the first product? It's 1, 2, 3 carbon. 3 carbon का carboxylic acid है. So you have to prepare like 3 carbon alcohol. Means propanol. Okay, just prepare the propanol. 1, 2, 1, 2, 3. Okay, 1, 2, 3 carbon, and here you will attach it. That is here. The propanoic acid gets converted into or gets reduced into a propanol. Next one. Yes, Kutsia, tell me. What will be the product in this case?
We should replace COH by CH2OH.
Yes. So this is a cyclopentanoic acid. Cyclo. So you will cyclic structure. Okay, and here you will write CH2OH. CH2OH. Okay, next one, Ali.
Benzene, then in place of COH, CH2OH.
Yeah, CH2OH. Okay, and fourth one. Yes, Rimda, fourth one.
Ma'am, we replace COH with CH2OH.
Okay, and what about this ketonic group? There are two groups, ketonic group, CO group, and this carboxylic acid. Just think about it. As I told you, this lithium aluminum hydride is the strongest reducing agent. So it will reduce any of the group. So this ketonic group will again, this CO group will get reduced to OH. Okay. Okay. Now see this sodium borohydride and catalytic hydrogenation. Sodium borohydride NaBH4, okay, and this H2 hydrogenation means H2 in the presence of any catalyst. So catalytic hydrogenation do not convert carboxylic acid to a alcohol. Just remember that because these are not as strong as the lithium aluminum hydride. So this sodium borohydride will only reduce carbonyl compound. It will only reduce carbonyl compounds, mean aldehyde and ketones only. Okay, just remember that. So you will not use sodium borohydride and H2. Okay, H2 in the presence of this catalyst, nickel or palladium or platinum, any of the catalysts, they do not convert the carboxylic acid to a corresponding alcohol. Okay, now suppose we have this structure. We have this compound and we are just using the sodium borohydride as a reducing agent. Okay, we are just using the sodium borohydride. Now, what will be the product? Just think about it. Suppose this is your first carbon, this is your first carbon, this is the second carbon, and this is the third carbon. Now, tell me which carbon will get reduced to which group? Okay, so starting from the Ali. Yes, Ali, tell me what will be the product in this case? We are using sodium borohydride.
OH in presence of ketone
Okay, good.
and CH2OH in presence of CHO.
And what about the COOH?
It will stay the same.
Yeah, will stay the same. Okay, because the sodium borohydride can't reduce this carboxylic acid to alcohol. Okay, so it has the ability to reduce the carbonyl compounds only, ketone as well as the aldehyde. So it will not reduce. The carboxylic acid will stay as it is. Clear, Imran Kutsia?
Yes, ma'am.
Yeah, one more thing, because this lithium aluminum hydride is quite expensive. Okay, so when we do the commercially when we prepare the alcohol, so we just don't use the lithium aluminum hydride because it is quite expensive. So first we just treat the carboxylic acid to a ester. फर्स्ट हम क्या करते हैं कार्बोक्सिलिक एसिड को एस्टर में कन्वर्ट करते हैं and further catalytic hydrogenation because catalytic hydrogenation ester का हम कर सकते हैं, right? So that's why first we just convert the carboxylic acid to a ester and then ester का catalytic hydrogenation करके we just achieve the alcohol. So we don't use this expensive material which is lithium aluminum hydride. So instead of this step mechanism, we just follow the two-step mechanism. First step, this carboxylic acid gets converted into ester, and that ester on the catalytic hydrogenation will give you a corresponding alcohol. So we use this due to the expensive behavior of lithium aluminum. So let's see the reaction. So suppose we have our COOH. So how we can achieve the how we can convert this carboxylic acid to ester? Okay, so you know very well, you are very aware of the esterification reaction. What is esterification reaction? When carboxylic acid is treated with the alcohol, so it will give you a ester. This is esterification reaction. So suppose this RCOOH, the carboxylic acid, and on treatment with R-OH, alcohol. जब आप इसे treat करते हो alcohol के साथ, so you will get a RCOOR dash. And what is this? This is your ester. What is this? This is your ester. So when you convert the carboxylic acid into ester in the first step, and after that on the catalytic hydrogenation H2 in the presence of a catalyst, nickel. Suppose we just take the nickel catalyst. So it will get reduced to a corresponding alcohol. So what you will get CH2OH. CH2OH. The number of carbon will be same. What you're supposed to do, just remove these groups. Okay, just remove this group and you will get CHRCH2OH. RCH2OH. Is it clear? This one? How we can convert the carboxylic acid to ester, and further catalytic hydrogenation will give you a corresponding alcohol. And yeah, one more thing, lithium aluminum hydride can also convert esters to a primary alcohol. Right? So lithium aluminum hydride can also convert esters को भी convert कर सकता है to a primary alcohol. So suppose we just take the ester R dash, okay, and when you put the lithium aluminum hydride, okay, reducing agent, the strongest reducing agent, so it will convert this ester group to a RCH2OH plus R dash OH. R dash OH. So what happens over here? So this group will get RCH2OH. So basically what happens, due to this alkyl group will form the corresponding RCH2OH group, and this R dash will give you R dash OH. Okay, so both you will get a mixture of alcohols. Mixture of alcohols milega, and both are the primary alcohol. You can see both alcohol are the primary alcohol, but both alcohols are different. So the R dash group is there, the other alkyl group, and here the different alkyl group. Both the alkyl group is different from each other, R and R dash. So you will get a mixture of alcohol. So on the further आपको purify करना होगा. Further आपको purification के need होगी to achieve that alcohol what you need. What you want to prepare the alcohol. So you need a further purification. So lithium, the main motive is to understand that lithium has also the tendency to convert esters to a primary alcohol. You can also use this lithium aluminum hydride convert ester to a primary alcohol. Okay, and that's the reaction. That's the reaction. And yeah, sodium borohydride can't convert esters to alcohol. You know very well, because it is not as strong as the lithium aluminum hydride, and it only convert the carbonyl compounds. Okay, it can't convert ester, it can't convert carboxylic acid, etc. No. Okay, just quickly do this question. This is the question, right? First is when you treat this compound with the sodium borohydride. So which group will get reduced? Which group will reduced, and when you do the catalytic hydrogenation, H2 in the presence of nickel, and when you use the lithium aluminum hydride as strongest reducing agent, so what will be the, so in all the three cases, write down the product quickly. Done, Ali and Vrinda? Yes, Vrinda. Tell me the first one. When you when you use the reducing agent NaBH4, sodium borohydride, then what will be the product? Just tell me which group will get reduced. Just write, it's very simple.
Ma'am, O will turn into OH.
This, okay. This ketonic group will get converted to OH. Okay. Next one. What is
OCH
this group? Yes.
CH2
CHO, OH. CHO will, sorry, CH2, CHO will get reduced to CH2OH. Okay, one carbon is there. So you will write the number of carbon should be same and you will write CH2OH. And what about the other groups? The COOH, will it reduced? The COOH, this is the carboxylic acid. And what is this? This is your ester. COOCH3. This is your ester. Will they get reduced in the yes or no? They will not get
No, ma'am.
reduced. Yeah, so because you are using the NaBH4, so it will only reduce the ketone and your aldehyde. Okay. So the other groups you will write as it is COOH group, and this is your ester group. So this is your product. This is your product when you treat it with sodium borohydride. The next one, yes, Putsia, tell me the product in the second case when you do the catalytic hydrogenation.
Yes,
When you do the catalytic hydrogenation, then catalytic hydrogenation will reduce which group?
COOH2 CH2OH.
See, suppose this is your first group, A group, ketonic group. This is your B group, ester group. Suppose this is your C group and this is your D. Now tell me which group will get reduced to which one? A, B, C, or D?
Uh, A will get reduced to OH.
Good. What
B
about the
will
B? B,
B will get reduced to CH2OH.
CH2OH. This whole thing is your COOCH3. COOCH3. So it will again reduce to your alcohol. Okay, this whole group will get reduced to a 1, 2, 3. 1, 2, this one. So here you will just remove all the groups. So it will get reduced and you have to just attach the OH. Okay, OH लगा देना आपने. This whole thing will get reduced to a alcohol, corresponding alcohol. And what about the aldehyde CHO group and COOH group?
COH will not get reduced.
Okay. Okay. And what about this aldehyde group?
CH2OH.
Yes, good. CH2OH. Okay, so the number of carbon should be same here, and you will write CH2OH. Good. Yes. Next, Ali. Next case, when this compound on treatment with lithium aluminum hydride. So what will be the product, and which group will be reduced to which one?
Ketone will be reduced to OH.
Mm-hmm. Okay, continue.
And
Ketone will get.
aldehyde will get converted to CH2OH, and carboxylic acid will get converted to CH2OH. And
This whole ester group you will remove and this will get reduced to OH. Okay, ester will get converted to a prime. So that is the role of different reagents. Okay, so you have to just keep this in your mind. Sodium borohydride will reduce only carbonyl compounds. Okay, ketone and aldehyde. The catalytic hydrogenation, other than like other than carboxylic acid, all groups can be reduced by a catalytic hydrogenation, other than carboxylic acid. And this lithium aluminum hydride, because it's the strongest reducing agent, so it can reduce any of the group, each and every. Okay, now the next method of preparation is from aliphatic primary amine. From aliphatic primary amine, how we can prepare the alcohol. Okay, so suppose we have a primary amine NH2. So this is a amine RCH2N NH2, right? Suppose this is a general form of aliphatic primary amine, and on treatment with HONO, okay, HNO2. What is this? So basically, this HNO2, it basically when you treat sodium NaNO2 plus HCl, this combination NaNO2 plus HCl will give you a HNO. Okay, तो आप क्या आप when sometimes you will see on the arrow above the arrow this HONO is written, or sometimes HNO2, or sometimes NaNO2 plus HCl. Okay, so this combination, basically this combination you will use when you need this one, nitrous oxide. Okay, what is this nitrous oxide? HNO2. So this HNO2 is also written as HON. HONO. Oh no, you can write. आप ऐसे याद कर सकते oh no. So whenever the from aliphatic amine, how we can prepare the alcohol? So by treating it with a oh no. Okay, HNO2, nitrous oxide. So on treatment with HNO2 or OH and O, so how we can write down the यहाँ पे ये भी show कर लो NaNO2 plus HCl. So by using this combination, ये आपको मिलता है. It just generate this HON. Now let's understand the mechanism first. So this is RCH2NH2. This is RCH2NH2. Now OH get attached to this carbon and this NO. Let's understand this mechanism. What happens is HONO, NHNO2. So this OH gets attached to this carbon. OH gets attached to this carbon, and this N2 from here. So what happens? This HRCH2OH, okay, so it will give you a primary alcohol RCH2OH. यहाँ से ये bond break हो जाता है. This CH2 and nitrogen, this bond will break, okay, and you will get RCH2OH. So OH of this nitrous oxide, OH gets attached to the carbon, and it will give you a RCH2OH. Alcohol मिल गया आपको. Now this N2 gas will be liberated out, plus what it will give? H2O. 2 hydrogen plus oxygen, so it will give you H2. So that is the mechanism. Okay, so OH and O आप लेते हो by the combination when you treat NaNO2, okay, plus HCl, so it will give you a HNO. Okay, and HNO2 will be treated with the aliphatic primary amine, and it will give you a alcohol, primary alcohol, plus N2 gas will be liberated out, and plus water. So that is the mechanism. Clear to everyone?
Yes, ma'am.
See these examples. Do this example quickly. This is the carbon. What you are supposed to do, just break this bond. Okay, and this carbon से क्या attach हो जाएगा? OH. Okay, and this nitrogen will be liberated out, and ये H2 and oxygen. So H2O will be. So you will get 1, 2, 1, 2, and OH. 1, 2 ethanol plus N2 plus H2. That is the product. Same here. This is the carbon. This bond you have to break. Which bond you have to break? This carbon and nitrogen bond. Okay, so this OH gets attached to this one, OH. And from here, the nitrogen N2 will be released and H2. Right, so what happens? OH, cyclopentanol plus your N2 gas plus water will be left. That is the. So from these 6 methods of preparation, you can prepare a corresponding alcohol. Okay, let's see a quick review. The first, हमने क्या देखा था? First method of preparation was from the alkene. So in the alkenes, we have done the acid catalyzed hydration. Okay, acid catalyzed hydration is in when you use the acid as a catalyst. Okay, so acid as a catalyst to form the alcohol. And in this, for the unsymmetrical type of alkane, you have to follow the Markovnikov addition rule. Second was the by acid by hydroboration oxidation. Okay, so hydroboration oxidation is the addition of borane followed by the oxidation. That is the hydroboration oxidation. And in hydroboration oxidation, we follow the anti-Markovnikov addition. Okay, anti-Markovnikov. Third one, we have discussed from the haloalkenes. From the haloalkenes, we can prepare the alcohol by a nucleophilic substitution reaction. Okay, by molecular nucleophilic substitution reaction, say you can prepare the corresponding alcohol from a haloalkene. Fourth one was from the carbonyl compounds. By the reduction of aldehyde and ketones, we can prepare the corresponding alcohol. And for the reduction, we can use these reducing methods. H2 in the presence of a nickel, palladium, or platinum catalyst, right? And this is known as catalytic hydrogenation. Hydrogenation, the addition of hydrogen in the presence of a catalyst. Okay, the second one was a very strong oxidizing reducing agent, lithium aluminium hydride. Third क्या था? Sodium borohydride. And the fourth one was sodium in the presence of ethanol. Okay, so on the reduction of this carbonyl compounds, we can prepare the alcohol. Next one, we have done the, in the same thing, we have done the reaction with Grignard reagent. Reaction of carbonyl compounds with Grignard reagent. Okay, now next one, carboxylic acid का हमने देखा. From carboxylic acid, how we can prepare the alcohol. Okay, on the reduction of using the lithium aluminium hydride, you can prepare the corresponding alcohol. Next was the last preparative method was from the aliphatic primary amine, and in this we use the aliphatic primary amine on treatment with HON. Right? Oh no, you can remember like this. Oh no. So you will get a corresponding alcohol plus N2 gas will be liberated out plus water. Right? So that is the mechanism. That these are the 6 method of preparation. So just please go through that and just practice more questions based on that. Next is the method of preparation of phenols. Okay, method of preparation of phenols. The alcohols का हमने finish कर लिया. The nomenclature part and the method of preparation. Now it is the method of preparation of phenols. Okay, so let's see one by one. What is the method of preparation? Okay. So from benzene sulfonic acid. From benzene sulfonic acid, how we can prepare the phenol? From benzene sulfonic acid. Sorry. Now, so what is benzene sulfonic acid? So first you should know how we can prepare the benzene sulfonic acid from benzene. Okay, so let's see. So suppose we have a benzene. This is your benzene. And when you add concentrated H2SO4, concentrated H2SO4, right? So concentrated H2SO4 will give you a electrophile which is SO3H. SO3H as an electrophile. And this electrophile will get attached to this benzene ring and you will get a benzene sulfonic acid. So it's an electrophilic substitution reaction. What is this? This is an electrophilic substitution reaction. Benzene on treatment with concentrated H2SO4, right? So the electrophile here is SO3H plus, right? So it will get attached to this carbon. Okay. Benzene is a electron-rich species. So this electrophile will come and get attached. So this is the benzene sulfonic acid. What is this? This is a benzene sulfonic acid. Now, how we can prepare phenol by a benzene sulfonic acid? So first, when you add sodium hydroxide and when you give some heat, so what happens? It forms a phenoxide ion, sodium phenoxide ion, O minus Na plus. So what is this? This is a sodium phenoxide. And the sodium phenoxide, one on treatment with H plus, okay, the acidic hydration, when you do the acidic hydration in the presence of an acid, so it will give you a, okay, so the sodium will be replaced by a hydrogen group and you will get a phenol. You will get a phenol. So that's how from benzene sulfonic acid, you can achieve a phenol. Is it clear? These steps? Yes? Is it clear or any doubt in any step?
Clear, ma'am.
Next is here from haloarenes. Okay, now tell me, is the nucleophilic substitution reaction of haloarenes are possible? Is the nucleophilic substitution reaction of haloarenes possible? Yes or no? Yes or no? Yes, Kutsia? No? No. Nucleophilic substitution reaction of haloarene is not possible. Why it is not possible? See, this is a haloarene. Okay, this chlorine is attached to this benzene ring. So what happens? There will be this chlorine. Chlorine is basically it just share the electron to the benzene ring. Due to that, the electron density increases on the benzene ring, and this chlorine is basically involved in the resonance with this benzene ring. The chlorine carries this halogen atom is involved in the resonance with this benzene ring. And due to the resonance, there will be a partial double bond character between the carbon and the halogen atom. And this is very difficult to break. So due to the partial double bond character between the carbon and the halogen atom, this bond, so benzene ring, this haloarenes don't show the nucleophilic substitution reaction at room temperature. At room temperature, but at certain drastic condition, like when you give the high temperature and pressure, so the nucleophilic substitution reaction is possible, and that reaction is known as dose process. That process by which the haloarenes show the nucleophilic substitution reaction and it will give you a phenol. This process is known as dose process. Okay, so just write down this process is known as dose process. This is important, right? So from haloarenes, how you can prepare the phenol? By a nucleophilic substitution reaction. By a nucleophilic substitution reaction. Suppose this is a chlorobenzene, right? Haloarenes, chlorobenzene. And in the first step, you just treat it with aqueous sodium hydroxide at 623 Kelvin and 300 atmospheric pressure. At drastic condition, this process occurs. At very high temperature and very high pressure, this nucleophilic substitution reaction in haloarene is possible, but not at room temperature. It is not possible at room temperature. Okay, so this is a chlorobenzene, right? First step में आप क्या करते हो? When you treat it with aqueous sodium hydroxide at this temperature and this pressure, okay, and in the second step, followed by the acidic hydration, so it will give you a phenol. It will give you a phenol. Now let's understand the mechanism. What is the mechanism here? Okay, so suppose we have this chlorobenzene. When you treat with NaOH, treated with NaOH at 500, like 500 to basically the temperature range here is 573 to 625. Okay, this range 623 you can, and 300 atmospheric pressure. What happens here? What happens here? This chlorine and this hydrogen, it will be removed as HCl. Now से HCl निकल जाता है and you will get sodium phenoxide, O minus Na. So here the sodium phenoxide ion will be sodium phenoxide. Next step, when you add the acid like dilute HCl आप डालोगे. Okay, so dilute HCl has H plus ion, right? It will give you H plus ion. So what happens? This H plus ion will get attached to this oxygen and the sodium will be removed. So this will be removed and it make bond with this chlorine, and here the phenol will be formed. Okay, then sodium will be removed out and this hydrogen will get attached to this oxygen. So it will give you a phenol plus NaCl. Okay, so no need to write down the byproduct, just write down the main product, phenol. You will achieve phenol by using this process. So that is the whole mechanism. First step, the nucleophilic substitution reaction. Okay, by this you will achieve the sodium phenoxide, and the sodium phenoxide on further acidic hydration, you will get a phenol. Okay, very simple mechanism. Is it clear?
Yes, ma'am.
Okay, see the next one. From diazonium salt. Now, what is diazonium salt? So let's see what is diazonium salt. So suppose we have this aniline, okay, benzene and NH2. Okay, we have aniline. When you treat it with NaNO2 plus S, so you know this combination will give you a HONO2, right? HNO2, right? HONO. So when you treat this aniline with NaNO2 plus HCl at this temperature, so it will give you a benzene diazonium chloride. ये क्या बन जाता है? Benzene diazonium chloride, and this is diazonium chloride. Diazonium chloride, when on benzene, N2Cl is present. N2, 2 nitrogen. Okay, it is 2 nitrogen. It is attached by a 3 bond and Cl minus. And nitrogen पे plus charge है, and this chlorine will have the negative charge. So this structure is known as benzene diazonium chloride or benzene diazonium salt. Okay. And further, when you treat it with dilute H2SO4, dilute sulfuric acid आप देते हो, so it will give you a H plus and OH minus sign, right? And this N2, it is a good living group. This N2 is a good living group, so it just leave the group, and here you will form, it will give you a phenol. This whole thing will get removed and you will get a OH. So the benzene diazonium chloride में when you put the dilute H2SO4 and आप कुछ heat दोगे, provide करोगे, so it will give you a phenol plus N2 plus HCl. Okay, plus N2 plus HCl. So what happens? This N2 is a good living group, so it just left. N2 gas release हो जाएगा, and the Cl which has a negative charge, it get attached to this H plus. It get attached to this H plus, and HCl will be removed out. And this OH minus, it's a good, it's a nucleophile, right? So it will get attached to this benzene, and you will get a phenol. So by benzene diazonium chloride, you can also prepare the phenol. Okay, just quickly write it down. Then okay. Let's see the next method of preparation from cumene. And the question is, what is cumene? Cumene is basically isopropyl benzene. What is cumene? So cumene is isopropyl benzene. So this is a benzene ring. This is a benzene ring. And benzene ring pe isopropyl. This one. This CH, okay, and this CH3, CH3. What is this? This is the isopropyl. Isopropyl group is attached. So this is your cumene. This is your cumene. And the other name you can write isopropyl benzene is known as isopropyl benzene. Okay. Now let's understand how we can prepare the phenol by a cumene. So this is a cumene, when you do the oxidation followed by acid hydration. Oxidation, first step में आप oxidation करोगे, followed by a acid hydration. So you will get a phenol plus your acetone. Okay, and this reaction is very important and this is very useful reaction because commercially phenols are prepared by using this method only, right? Why? Because it has application, because you can see the byproduct here is very useful byproduct. The byproduct is acetone and acetone का बहुत use होता है, बहुत applications. So commercially, the phenols are prepared by using cumene. Why? Because it gives a useful byproduct, okay, which is acetone, which is propanol, and what is common name of propanol is acetone, CH3COC. Okay, so this is the general reaction. Now let's understand the mechanics. So first, you just take the cumene. This is cumene. Okay, isopropyl. This CH. This is a benzene. And here CH and CH3, CH3, isopropyl benzene. First step पे क्या होता है? You will do the oxidation. Okay, oxidation. In the presence of any catalyst like HBr of catalyst use कर सकते हैं. So first step is oxidation. So oxidation will give you a peroxide bond. So what happens between this carbon and hydrogen? There will be a peroxide bond, O2 bond. यहाँ पे बन जाता है. Right. So what happens? This O2, first step will be the oxidation, means the addition of oxidation. Carbon, the CH3 as it is. And between this carbon and hydrogen, two oxygen get attached. The addition of two oxygen means you will see over here, this is the peroxide bond. So it will, on oxidation, it will form a peroxide bond. Now, what happens next? Next, क्या होता है? When you add dilute HCl. So what happens? It will give you H plus. Basically, you are just doing the acidic hydration. What is this step? Acidic hydration. Hydration in the presence of a acid. Okay, so H plus in the presence of H2. You are doing this. So what happens in acidic hydration? This whole thing, CH3, CO, and CH3 will be removed as acetone. What is this? CH3, CO, CH3. This is acetone. So acetone will be removed and you will get a phenol. So what happens? You will get this OH bond gets over here. It rearranges itself to here. So it is phenol. So you will get phenol plus this whole thing. What is this? CH3, C, double bond O, and CH3. You will get acetone. So that is the whole mechanism. First step, oxidation. Okay, means the superoxide bond will be formed between the carbon and hydrogen. Two oxygen will be added up. And the next step, when you do the further acidic hydration, what happens? This whole thing, acetone will get removed. Okay, and you will get a phenol. So this reaction is also known as auto-oxidation. Okay, this reaction is also known as auto-oxidation. Okay, खुद से oxidation हो रहा है. And this phenol, why this reaction is important from the cumene? This is important reaction. Mark it as important one. Why it is important? Because commercially it is phenols are prepared by using this method because it gives a useful byproduct which is acetone. Right? So that's why it is important commercially. Clear to everyone? Yes.
Yes, ma'am.
Any doubt? Rimda, Kutsi, Ali?
Oh, no.
Okay. So see, we have done this. Like in method of preparation of alcohols. So we have done 1, 2, 3, 4, 5, 6, 6 reactions. Okay, 6 reactions हमने पढ़ा है, discuss किए method of preparation of alcohols में. First one is from the alkene. Okay, and alkenes में हमने क्या देखा? Acid catalyzation. Okay, acid catalyst की presence में. So H plus and H2O as a reagent we use, and we use Markovnikov addition. Markovnikov addition rule means OH will get attached to that carbon which has less number of hydrogen, right? And vice versa. And the second reaction from alkene is hydroboration oxidation. In hydroboration, we use diborane. Okay. Further, in the diborane in the first step, followed by the H2O2, hydrogen peroxide. Okay. And in this, we use the anti-Markovnikov rule. हम क्या use करते हैं? Anti-Markovnikov. So just remember, first one में acid catalyzation में हम क्या use करते हैं? Markovnikov addition rule. And in the hydroboration oxidation, when you see on the arrow, there is a diborane, okay, in the presence of H2O2, hydrogen peroxide. So you will use anti-Markovnikov addition, just opposite to that first one. Okay, so this was the first reaction from the alkene, how you can prepare the alkene. Second, we have done from the carbonyl compounds, aldehyde and ketone. First one, we have seen the reduction. On aldehyde on reduction, it will give you primary alcohol, and ketone on reduction, it will give you a secondary alcohol. Okay. Now, Grignard reagent के case में हमने क्या देखा? Formaldehyde on treatment with Grignard reagent will give you a primary alcohol. And other aldehyde like R's CHO group. Okay. So when you remove hydrogen from the formaldehyde and you place the R group, any alkyl group, so it will become other aldehyde other than formaldehyde. So when you treat other aldehyde with the Grignard reagent, you will get secondary alcohol. And when you use a ketone on treatment with Grignard reagent will give you tertiary. These things, this flow chart, just remember this one, and just remember the trick, how you will use, which rule you will use, and how you will write on the product. Okay. Now the third one, carboxylic acid. So only LH. You will use lithium aluminium hydride to reduce the carboxylic acid. Only lithium aluminium hydride has the ability to reduce the carboxylic acid to a corresponding alcohol. Okay. Next one, ester. Ester, yeah. So two things you can use as a reducing agent, lithium aluminum hydride plus the catalytic hydrogenation. You can do the catalytic hydrogenation. H2 in the presence of any catalyst, palladium, nickel, or platinum, any catalyst. Next is from haloalkane. Okay, alkyl halide. So from alkyl halide, when on treatment with sodium hydroxide or potassium hydroxide, so it will give you a corresponding alcohol. And via bimolecular nucleophilic substitution reaction. Okay, and the last one method we have done from the aliphatic primary amine. Okay, and which reagent we use? So we use HNO2, nitrous oxide, NaNO2 plus HCl. This combination will give you HNO2. Okay, and on this treatment, on the treatment with RNH2, it will give you a corresponding alcohol plus N2 gas plus your water. Right? So these are the summary of what we have done till now. Okay, so basically we have, these are the method of preparation of alcohols. Now, method of preparation of phenols, there are not much methods. First method is from benzene sulfonic acid. Second method is from the haloarenes by the Brose process. Third is your from disonium salt, benzene disonium salt, and the fourth one is your cumene. Okay, so just please revise the notes. Okay, practice